Here's another problem from Module 3, Topic 2, Lesson 1, Strategic Solving from Activity 1.3. We will be solving this problem right here. There's a couple strategies that we can use. Last time we saw that we didn't have to actually do anything to the equation. We could just simply solve, like let's say maybe I wanted to add 3 5/10 x to this side, whatever it may be. I would like to expand on the piece about what happens when I have decimals and what I can do with those decimals. In the previous problem, we saw that we just had things out to the 10th place, and all of the decimals were out to the 10th place, but this one comes out to a decimal into the 100th place. So what I'm going to do with this, I'm actually going to do something that might seem a little bit scary. I'm going to multiply the entire equation times 100 because I have 2 place values here. And if I just multiply by 1 place value, 1 power of 10, it wouldn't quite make this decimal go away. But by doing this, what I end up with times 100, I end up with 1,211 times x minus 1,050. Notice right here with that value, if I looked at all of these, I have to consider that if this one is to the hundredths, then maybe each of these should be to the hundredths, and maybe that'll help me a little bit. Then we have 7,560 minus 350 times x. And you might be thinking, wow, that's a lot of really big numbers. I'm not sure I want to do this. That's okay. Go back and do this without multiplying by 100. Just simply follow the properties of, or the properties of equality. For this one, I'm going to go ahead and bring my variable term to the left-hand side, 350 times x. So I'm going to add 350 times x to the negative 1,211. I'm going to go ahead and grab a calculator to hopefully make my computation just a little bit easier. We will take 1,211 on the negative and add 350 to it to give me negative 861 times x minus 1,050 is equal to 7,560. From here, I want to use the addition property of equality to eliminate the constant term from this expression on the left and bring it over to the constant term on the right, leaving me with just the variable term on the left and only a constant term on the right, which is 8,610. And now I want to go ahead and use my division property of equality, dividing negative 861 on each side. And then I'll take my value, 8,610 divided by negative 861, and I get 10. So I suspect my work tells me that x is negative 10. Now, to make sure that I'm right, I need to verify. Again, I'm going to use my original equation, but wherever I have an x, I need to change that or substitute that for x equals 10. So let's check our work. We will go like this with negative 12 and 11 hundredths, replacing x with negative 10, minus 10 and 5/10. And I'm wanting that to be, I'm hoping that will be equal to, I'm questioning if my answer makes these equal, then 75 and 6/10 minus 3 and 5/10 times negative 10. Here we go, each side. 12 and 11 hundredths. Whoops, didn't get all my buttons. A negative 12 and 11 hundredths times a negative 10 is equal to 121 and 1/10. And then I'll subtract the 10 and 5/10 from that, giving me 110 and 6/10 for my expression on the left. So that's my simplified expression when x is negative 10. And now I want to work on this side over here, and I hope that I get that 110 and 6/10. We'll get rid of that. So we have 3 and 5/10, and we see that minus sign. So we're going to treat that like a negative, times a negative 10 is going to be 35. So 75 and 6/10 plus 35. Whoops, not times, plus 35 is equal to 110.6 or 110 and 6/10. Moment of truth. They are equal. That's awesome. That means that my solution that I came up with, x equals negative 10, is correct. Now, like I said, you could go from the very beginning. not multiplying everything by 100. And if you follow your properties of equality exactly the same way as I did, you will get this exact same solution. We just have to be really careful to follow the rules. All right. Let me know if you have any questions. See you on the next one.